Okay. Question, sir? Yes. I've got pencils up here. You'll need to sharpen it, though, because I don't think they're sharpened. So there you go, sir. Okay. All right, so patty paper, pencils in hand here. Let's get started on this. Number 2, it says to do a counterclockwise rotation of 30 degrees around point P. All right, so here's our little picture there. I'm going to zoom in some on that so we don't have to worry about all this other stuff here. All right, so I want to take this triangle here, ABC, and we're going to rotate it around this point P. So let's put some points, some vertices on that triangle, ABC. All right, put some vertices on that. And let's then get started on our rotation. All right, so what's the first thing we should do here to start this rotation? Anybody, what should we do? Yes, exactly right. So we first need to connect P to one of our 3 vertices here. A is the best choice, Alex. It's the closest, so I'd say it's the best choice. Yep. But really, it's any of those points you can connect. All right, so now we've connected it. Very good. All right, and now we're going to measure our rotation. So counterclockwise. Does that mean we're going to kind of rotate up this way, or we're going to rotate down that way? Up, right, okay, counterclockwise, it's always counterclockwise around P. So counterclockwise is this direction. So we're going to rotate this way 30 degrees. So now it's important we take our protractor and we measure accurately here. Oof, and my protractor does not quite fit. I have to like bend my book back there. Okay. Bless you. Okay, so again, this is the side of the angle we want to measure. Okay, we're going to measure up from there. So I'm going to start at the 0 and go, there's 10, 20, there's 30, and I'll mark off right there at the 30. And then we'll draw that side of our 30-degree angle using our protractors there. Okay, like so. Create a little ray there. You don't have to label this ray. And that's 30 degrees. Okay, there's our 30-degree angle. All right, so we've got our 30-degree angle, but now we need to actually like rotate our shape. How do we do that? Alex? Trace it. That's right. So patty paper on the picture here, and we're going to draw point P. Okay. We need A, we need point C, and we need point B. All right. And I'm also going to connect, whoops, also it's a good idea to connect P to A as well. Like so. Okay, you want to connect those. And then we just do the rotation. Keep point P on point P, right? We want to rotate it. Point P should stay on point P, and you just line up to the new side there, and there's where a point should go, right there. Okay? There's where they're going to go. Now, I need to draw on the backs of these points, though, because they're not going to transfer. All right, so I'm going to quickly draw on the backs of A, B, and C. Okay, you have to like darken in the backs of A, B, and C, because otherwise the points won't transfer over. And you can see they already transfer when I do it that way. All right, so once you've drawn on the back, go back to that rotation there.
Should we make this square on the back too?
No, you don't have to. All right, and then just transfer. Once you've drawn on the backs of A, B, and C, do the rotation once more, and the points should, there they are. See, they transfer. Okay, just like that. And then we can darken those in. All right. And so there's my rotated triangle. Okay, so again, what do we do? We copied point P, A, B, and C. All right. We drew the line from P to A like we had there. We drew on the backs of points A, B, and C so that they would transfer, and we just rotate our paper there until we get PA to line up to the new angle, the new side, and then we just draw over A, B, and C, and it transfers the points. Okay, points are transferred. And you can reconnect the dots, and now we're almost done, but we still have to name the points here, right? Can't just do. So right, how should we name these? So this point right here, well, that rotated from point A, so this is A prime, right? This point right here, what did it rotate from? It rotated from C, so we're going to call it
C prime.
C prime, and then B rotates to B prime. Okay? All right, very good. Questions on any of that?
Yeah, pretty much when you're rotating it, the line that you make for like C to A,
Yes.
you want to line that up with the line you made.
Yes, that guarantees if you keep P on point P. In fact, if you want to, you can even like put your pencil point there on point P, so that way point P will kind of stay stationary. And then you can see that you just rotate it so that it lines up with a new angle. That guarantees we've done a 30-degree angle rotation right there, because that's the side. We rotate from one side to the other. That's the 30-degree angle there. Okay? All right, let's try another one here, where we're going to scoot down to number 5. All right, now, number 5, this is one I was showing you guys yesterday, where we're told to draw the image of the figure under the given rotation. All right, and we're told to rotate triangle ABC 270 degrees. But what's the problem with rotating 270 degrees using a protractor?
There's not one.
Yeah, it doesn't go to 270, right? 270 is not an option on a protractor. What's the highest that a protractor measures to? 180. So, are they getting us something impossible for us to do?
No.
No, okay, it is not impossible. We can do this. Okay. So, by the way, we're also not told a direction. When we're just given the degree measure by itself like this, what direction do we assume we're rotating? I told you yesterday, counterclockwise, okay? So if we assume we're going to rotate 270 degrees this direction. All right, something like that. But the problem is we can't do that in that direction. So we're going to go the opposite direction, but how much? 90 degrees, exactly right. We'll do 360 minus 270, and that's equal to the 90 degrees. Okay, so that's what we'll do, but we'll do it in a clockwise direction. So this is counterclockwise, and we'll do 90 degrees clockwise. All right, so put some points down for A, B, and C. Okay. The steps are exactly the same as what we did before. Exactly the same as what we did before. Okay. That's the good news. The steps are almost exactly the same as what we did before. There's quite a few people here. Okay. So now we're going to take our paper. I'm going to kind of scratch out this previous work that I did there because I don't want that to confuse me. All right, and then I'll just, again, I forgot to connect B. I'm going to connect B to the center of origin there, or the origin, which is the center of rotation. Okay, and then we'll just trace. So, origin, and then our vertices. Okay. And you know what I forgot to do? I forgot to measure my angle. Yeah, I forgot to measure my angle. So that's okay. We didn't like miss any steps there. I mean, we're still going to have to do that in the first place. But I need to measure though before I'm going to do the rotation. So again, line your protractors up. And we're going to rotate 90 degrees. Now, some of you guys might already know, point B currently has coordinates -2, 0. What will B's new coordinates be? 0, 2. Yeah, careful. Yeah, 0, 2. Exactly right. If we're going to rotate 90 degrees, if B is right here on the x-axis, it's going to rotate 90 degrees up here to the y-axis. I mean, if you want to kind of like get a sneak peek at what it's going to look like, just take your book and rotate it 90 degrees. And there's what the new picture is going to look like. All right, this triangle will be in this is like now the first quadrant, it looks like, right? B is going to be there, A is going to be there, C is going to be there. That's what it's going to look like, okay? But now let's actually do it. Okay, so we can see that. So there's A, B, C, and now just rotate that paper. Oh, 90 degrees, sorry, is that guy right there. I forgot to mark it. I mean, you know, you can see here, it's just the x's. The x's. Okay. So it's that angle. So we're just going to take their paper here and rotate it 90 degrees. And there it is. Now here, You still can draw on the backs of these points if you want to transfer them, but you can also just like look through your tracing paper and see what the coordinates are going to be. For example, this point is at the coordinate 0, 2. So if you want to, you can just peel your paper back and just put a point right there. Okay, you look here and see this coordinate is at the coordinate 2, 4. And so again, you can just peel your paper back and just draw the point there at 2, 4. And then same thing for this point, it's at the coordinates 3, 2. So again, you can just peel your paper back and just draw those points in there if you want. Okay? And so we recreated our triangle, right? I'm going to even just freehand draw this. Oh, thank you. Okay. Freehand it, and there it is. All right, we need to rename our points, though, since they were transformed. So what's this point's name right here? B prime. And this one is? It's going to be A prime, and this one's then got to be C prime. Okay, and there they are. All right, questions on any of that? Are we feeling better about this? Alex, Josh, why are you not doing any of this?
Oh, I already have...
No, not Alex. I'm talking about Josh. Josh, why aren't you doing any of this? You got your books right there, Alex. Yeah, Josh, it's 20 minutes into class, and you chose to not follow along with this. That is not a wise choice, okay? You need to be working on this. I promise whatever is on your phone is not going to help you pass this class, but this will, so it's important you do it, okay? All right. I want to look at one more thing here, and that's we'll do two more things. All right, we'll do a quick one here. So number 9, I also showed you guys yesterday how to measure the angle of rotation. Okay, I also showed you guys yesterday how to measure the angle of rotation. Okay, so how do we measure the angle of rotation? Someone want to run us through this? How do we do this? What do we do here? Yep, Eli. Okay. Okay. So like X, it looks like here, right? And we'll draw, like connect them, you mean? Mm-hmm. Yep, exactly right. And then we'll just measure that angle. Right. Did we have to pick X and X prime? Could we have chosen another pair of points? Yeah, absolutely. If I chose Y, for example, then I would measure to what? Y prime. And if I chose Z, I would measure to Z prime. Okay? All you do is just connect the original or pre-image X. Like, for example, in this case, we did X to P, and then you connect its image, so the image of X is X prime. You connect its image to P, and you just measure. See, you created an angle. There's the angle right there. And just measure that angle. Sorry? You said 75? All right, let's see here.
Well, I measured the X.
Okay, that's fine. All right, so if I look here, if you line up P along here with the X, you look at the line there. You see it now? So it'll be 50 degrees. 50 degrees is what we want there. And that's okay. We're still getting some practice with the protractor too. But yeah, 50 degrees is what we get there.
How'd you get 55?
50.
Yeah, how'd you get 50?
So look at my protractor up here. Do you see how I lined it up? The line here, the bottommost line, right? I lined it up with a PX. And then there's P to X prime right there. And it goes through the 50. Now, if you guys need to extend that line, okay, extend it too. If you need to extend this side so you can like see it with your protractor, like extend it out real good there, so that way you can line it up. Okay. Did you figure out what it was there, Corey?
No, I just extended the line, that's all.
Oh, okay. Okay, so now if you extend it this way, you're good then?
Yeah.
Okay, good.
Thank you.
Not a problem. That's what I'm here for. 50 degrees. Okay. So we could say 50 degrees counterclockwise, but what other direction could we say? We could say what degrees clockwise? Not 130. You have the right idea, but not 130. 310. You want to subtract it from 360, not from 180, because we want to go the other direction around the circle. So yeah, it'd be 310 degrees if you wanted to. Okay, I'll leave the other one for you there. Number 10, some of you guys can maybe just eyeball it and see. What's that rotation there, number 10? It's 180, yeah. Very good. Okay, very good. All right, number 11. Let's take a look here. This is the last one I'm going to go over with you, and then we're going to get into reflections. Or maybe I'll have you guys try one, and then we'll get into reflections. Number 11, okay, we took this shape. So here it says, write an algebraic rule for the rotation shown. then describe the transformation in words. So if you look here, right, this is, well, maybe it's not so clear, but it is in fact a rotation. It says it's a rotation. We're told that. Yeah, it's 180, exactly right. So we want to come up with the rule for it, though. That means X, Y, arrow, and then we want to come up with the blanks right here. That's what we're trying to fill in, those blanks right there. Oh, sorry, you can't see those, right there. Okay? And so again, we can just, like, my suggestion is label the point. So for example, D has coordinates -4, 2, but then D prime changes to 4, -2. Okay? E has coordinates -1, 3. E prime has coordinates 1, -3. All right, F has coordinates -1, -3. And then F prime has coordinates 1, 3. G has coordinates -3, -4. And G prime has coordinates 3, 4. And now we want to try and see if we can see any pattern from how the original or pre-image is changing to the image. How does D become D prime? How does E become E prime, F become F prime, G become G prime? What's happening here? Our X coordinates, what happens to them?
Oh, so it's just the opposite.
So how do you make X opposite? That's exactly right. How do you make X? -X, exactly right. And then what happens to our Y coordinates? -Y, exactly right. There's the rule. That's all you got to do is like just write the pairs out and then look for the pattern. And the pattern is it just changes the opposite, like Alex and you guys were saying. Okay, good job there. That's it. That's how you write the rule for it. Okay, number 12 will have a similar kind of thing you need to do. All right. Okay. So what I would like to do then in the meantime is I'll go ahead and just I'll give you guys like 5 minutes. Go ahead and like continue working on this. Okay, another for like 5 or so minutes, and then we're gonna get into reflections. Okay, so just get started on the assignment. Again, what I have on the board for you, I'll write it back up here. It's 2 to 17. Skip number 13 and 16. Okay. Skip number 13 and 16. Okay, so go ahead and give that a shot. Give yourself some practice. We are going to be quizzing on this in the near future. I think this week we're going to be having a quiz, so you really want to make sure you're getting it down. 95 minutes. Oh, stapler is probably back in the back, on my desk. Okay. And I'll come around and help as necessary. Let me just make sure I took... And then I took... all my attendance accurately. Okay. Okay. You have questions? Awesome. Okay. What's up? Yeah.
So, for me, I think for, maybe I speak for other people here, that's my assumption that memorizing stuff is not, up there high. If you want to know, absolutely, and that's why I wanted an app to us that we're never trying, because if that's something you'd like to do, I would like, go give us your word on it, and go for it. Okay? Yeah, go ahead. So, go please, all right, you're going to need some, keep that down. So, okay, there's those The wheel rotates, so the car at the bottom of the line takes on the next car. Think about how many degrees does the wheel rotate? So there are some cylinders, okay, that go around the entirety of the Ferris wheel, right? So how many degrees is that forward? So if there's 20 cars, how many degrees is it on each clockwise?
How many degrees does the wheel rotate?
So you subtract 20, there's 20 degrees between
I
each
just need
car.
15. That's right. Understand what you're doing?
So if you want to think about these, I think you mean, yes. Yeah. Yes, sir. So again, here's the center of your clock. You want to go clockwise. So does the clock go this direction, or does the clock go this direction? Yes, so you want to rotate it up. Yes, sir.
Let me see what number 9, can I read it here?
Maybe I should know the
Oh, yes, it'll be 50 degrees counterclockwise, exactly right.
Good job, Tristan.
No, you wanted to.
Hey, Corey, you doing okay? You good? Okay. So we try 7 and 8, so you want to do those as well.
See what you said.
Hey, Josh, how are you doing on that? So, Josh, so it's why it's important you pay attention when I'm going over it and not on your phone, okay? So I'll show you once right here, but then we're going to get into your new stuff, all right? And then, you know, do you have a protractor? Oh, ask us. Were you, is this yours, Robbie? Yeah. Okay. I'll get you one.
Can I do this?
A clockwise rotation is 55 degrees around point J. That's our center of rotation. There's some points there. So, we're going to now net A to J, L to J, M to J, doesn't matter. I like to pick the closest point, so we just A to J. And the reason why we do this is this allows us to create a side for our angle of rotation. We're then going to put our protractor down and measure a clockwise rotation of 55 degrees. If this is the center of our clock, this is our center of rotation, so the center of our clock is right here. Which way is clockwise? We rotate up like this, we rotate down like this. You're not going to do clockwise, go up from here or go down? Yep, so it's going to go, well, so, you know, your right finger is going this way, so it's going to go this way. So it's going to go up like that. So you measure 55 degrees up that way, so you can center our protractor on the side there.
I know.
Okay? Try to center it on this one lined up there. I'm going to measure 55 degrees. We start at 0 and count up to there's 50 to 60. There's 55 right there. We're going to mark it. Okay, and then we're going to draw. A line. So that's a 55-degree angle right there. Okay. So. Oh, good. We practice our writing paper some as well.
Then you were aware, I was like.
Nope, not a problem. Oh, yeah, I mean, rotations are tough. This is the toughest rotation. This is the toughest that's involved in it. There's a big effort, right? As the lines drawn here, that way we rotate. You see our shapes rotate, right? It's turning along with this, and we're going to line up to here, because now we know, okay, from here to here, there's 55-degree rotation. So once we lined up here, we've now moved 55 degrees. We have these 3 points. The problem is, I need to get these points onto this paper, right? So I'm going to do that. I'm going to flip my paper over and draw on the back.
How you gonna get that picture?
If I draw on the back, now I'm not going to.
You're all good? Thank you.
Huh? When you're down there, that's not there.
Oh, right, okay, thank you.
Calculate that.
I get that. It's in terms of going full circle.
Probably not.
Yeah.
Oh, yeah, you just.
Okay, so there it is. That's transfer over, rotate it 55 degrees. K, rotate it prime. L, rotate it here, L prime. And rotate it down. There it is. Okay? They're not really, no. I think this is probably the easiest way to do it. No, that is the degree measure that I need. So think about it this way.
We'll keep going around.
Yes, exactly. Now, here's the thing.
I like that.
So what you do is this. If you take this shape and rotate it 300 degrees, it's right back where it is, right? And if you rotate it another 360, it'll be right back where it is. That's 360 plus 360, that's 720 degrees. So rotating it 720 degrees, brings it right back where it is. Add another 360, brings it right back. So keep track of 360s until you get to what the actual angle is.
Alright. Alright. So what do you have to do?